All right, guys. Welcome back, and thank you for tuning in to our final lesson here with the EI.2 notes on linear and absolute value inequalities. So up to this point, we have focused primarily on linear inequalities, and then we took a look at some compound inequalities, looking at doing more than one linear inequality at a time, and then looked at some word problems. Now we are going to get into absolute value inequalities. And absolute value inequalities stem from what we talked about last time with compound inequalities. So let's go ahead and let's jump right into our first section here on page 8, solving less than absolute value inequalities. So anytime we have a less than expression. When this is the case, let's say we have A that's an algebraic expression, and k, which is a number, it's going to be a positive real number. So remember, this R looking symbol here means real number, so any non-imaginary number, which we'll talk about later in this year, but it's got to be positive, so we're not dealing with negatives, because it's going to be an inequality, or sorry, an absolute value here. So if we have an absolute value that is less than k, it implies that we're going to have a compound inequality where a is still less than k, but also a is greater than negative k. So if you remember when we solved absolute value equations, when we wanted to remove the absolute value symbol here, we had to set up two equations where we had the constant that was once positive and the constant that was once negative. This is the same case, or the same concept that we're doing here with inequalities, but when we set up the inequality, we have to change the sign. Think about it's like kind of like taking k and multiplying it by a negative, then we would change the value of that inequality. So let's take a look at this in example. This occurs only when we're ready to get rid of the inequality symbol. So remember, if we wanted to solve for an absolute value, problem 7 says to solve each of the following inequalities and list the solution in interval notation. If we want to solve for an absolute value, we need to follow reverse order of operations, or SADMAP. So what I need to do here is I need to get rid of this 4. So because the 4 is dividing the absolute value, I'm going to multiply by 4. So that's going to give me the absolute value of 3x plus 2 is less than or equal to 4. Multiplied both sides by 4. Now I'm at a place where I need to get rid of my absolute value. So again, with linear equations, or sorry, absolute value equations, we broke this apart into two equations. We're essentially going to break this apart into two inequalities, remembering that 3x plus 2 is still going to be less than or equal to 4, but now it's also going to be greater than or equal to negative 4. So we're writing this compound inequality as one expression, but changing the value of the inequality when we change the positivity or negativity of the constant. Now I can solve this. So remember, with compound inequalities, if I subtract 2 from the middle, I need to subtract it from both of the outside constants. So I have negative 6 is less than or equal to 3x, which is less than or equal to 2. And then I'm going to go ahead and divide by 3. So when I divide by 3 here, I get, sorry, not divided by negative 3, divide by positive 3. I get 2 is less than or equal to x, which is less than or equal, sorry, negative 2 is less than or equal to x, which is less than or equal to 2/3. So this is my inequality representation of the equation. Now it does ask for interval notation. So if we wanted to draw this in a graph, we could. But if you think about this graphically, remember interval notation, what's the furthest left on the number line we're going to get? In this case, -2. And -2 is going to have a bracket around it, because we are going to, this symbol right here means we are going to be to the right of -2, but including -2 because it's equal. Then this symbol means we're going to be to the left of 2/3, and including 2/3 because it is equal. So the interval would be from -2 to 2/3. Okay, so basically to get rid of that inequality, when it's less than, we're going to create a compound inequality. Sorry, to get rid of the absolute value, we're going to create a compound inequality where we switch the sign of the constant and also switch the sign of the inequality. So if you think you have that concept, go ahead and see if you can try B. Let's take a look at B now. So B, Here in B, the absolute value is already by itself. So I didn't have to multiply, add, or subtract, do anything to get the absolute value by itself. It's already there. So now I want to get rid of the absolute value, which means I'm going to create that compound inequality. So 2x minus 7 is still less than negative 5, but now it's also going to be greater than positive 5. Now, we could potentially take a look at this expression and try to work this out. So let's go ahead and try to work this out if we want to. Just for the algebraic work, I'm going to add 7 to both sides, or 7 to all sides, and that's going to give me 12 is less than 2x, which is less than 2. And then I'm going to divide everything by 2. So 6 is less than x, which is less than 1. So basically what this expression says here, if you work this out algebraically, this expression says is we are looking for a number, some number, that is greater than 6, but also less than 1. And what you may immediately notice here is that this is no solution. X does not have a solution here. And so if we wanted to represent that, that notation is often the empty set. There's nothing in there. So there's no number that is greater than 6, but also less than 1. What we can see here is that this absolute value was less than a negative number. Go back up to our rule here. Absolute values that are less than only work when k, the constant over here on the right, is a positive number. So like we saw with absolute value equations. If we have an inequality with an absolute value that is represented, it's less than a negative number, that can't happen, so that answer is always going to be no solution. You could have done this without any work, or you could have worked through the problem and realized that, hey, I'm looking for an answer that's greater than 6 and but less than 1, and there's no number that exists, and so I come up with no solution. Either way. Now, a greater than expression, solving greater than expressions, is got a similar concept, but it's a little bit different. A less than is implying essentially an intersection, an and. A greater than is essentially implying a union. So if we have the same setup now, but in this case, a is greater than the absolute value of a is greater than the constant, that means a is greater than k, or a is less than negative k. So here we're going to split, we are going to have a compound inequality where we split into two equations. Same concept as the last time. I'm going to take it as the same representation with a and k, and then when I change to a negative k, I'm going to switch my sign. So let's look at that in some application. Let's go ahead and look at problem 8. Same directions as problem 7. I want to solve for x. So I need to get rid of this negative 1/3 out here. So I'm going to multiply by negative 3 on both sides. So if I multiply all this by negative 3, that's going to cancel out that negative 1/3. They're going to divide out to be 1. So I'm going to have 3 plus x over 2 in an absolute value. Now notice I multiplied by a negative 3. So when I multiply by negative 3, I have to change my sign. So this would be greater than 6. So don't forget those rules. If I multiply by a negative with inequalities, I have to change my sign. Now I'm getting ready to get rid of the inequality here. So what I do, because it's a greater than representation, it's not an and, it's going to be an or statement. So 3 plus x over 2 is greater than 6, or 3 plus x over 2 is less than negative 6. So either or. Now we can solve this for x, subtracting 3 from both sides. I'm going to do both of them at the same time because the steps are the same. So x over 2 is greater than 3, or x over 2 is less than negative 9. And then multiply by 2. So x is greater than 6, or x is less than negative 18. So these are my two possible answers here. If I wanted to, I could graph out this um, graph to come up with my interval, but let's look over here. This is saying I want everything to the left of negative 18. So left of negative 18 would go on to negative infinity, and then it would come to negative 18 with a parenthesis because it's not equal there. So that's one of our intervals. And we do usually go left to right, so that's why I did the negative infinity to negative 18 first. And then the other one is greater than 6. So it's going to start at 6, but with a parenthesis, and it's going to go greater than to the right of 6 forever to infinity. So this would be interval notation here. So the difference here with 8 is once we got to the absolute value, that absolute value was greater than a constant. So it implies an or statement. We're going to split this into equations. Let's take a look at B. Or actually, if you get this concept, go ahead and see if you can do B. Okay, hopefully you got an answer here. Let's go ahead and take a look at B. Now, what we may notice is that this absolute value of 5x plus 2 is greater than or equal to negative 3 halves. And so when we saw this scenario when it was less than a negative, when an absolute value was less than a negative, the answer was no solution. It did not exist. Now let's look to see what happens if the answer is greater than a negative. So I'm going to go ahead and I'm going to split this into two equations. So 5x plus 2 is greater than or equal to negative 3 halves, or 5x plus 2 is greater than, or sorry, not greater than, but less than or equal to positive 3 halves. So now I would solve for x. I'm going to subtract 2 over here. 5x is greater than or equal to negative 7 halves. And let me show you how we can do that in the calculator real quick if you struggle with fractions. So if I wanted to do that in the calculator, that quick subtraction, I could do negative, sorry, there we go, negative 3 over 2 minus 2. It could give me a decimal or hit math, and it puts it in a fraction. So if you need that help with fractions, your calculator will help you solve those. So now let's subtract 2 from the other side back to solving the equation. So 5x is also less than or equal to negative 1 half. Now I need to divide by 5 to get rid of that coefficient. And so what I would get here is x is greater than or equal to negative 7/10, or x is less than or equal to negative 1/10. So now, what this is saying, let me actually show you this one graphically. What this is saying is I have negative 7/10 over here and negative 1/10 over here, because negative 1/10 is closer to 0, negative 7/10 is closer to 1. So what I would be looking for is greater than or equal to negative 7/10. So anything going that direction, and also less than or equal to negative 1/10. So anything going that way would work. So what we can see is this is an or, not an and. So we're not looking for overlapping. We're looking for anything that's covered. And so this expression covered everything to the right of and including negative 7/10. This covered everything to the left of and including negative 1/10. So in our graph, we're covering everything. So with a greater than, if an absolute value is greater than a negative number, your answer is going to be all real numbers, or from negative infinity to infinity. And that kind of makes sense. So remember what an absolute value does. An absolute value takes any number and makes it positive. So if I have any value for x, it doesn't matter what that value is. I could put that value in for x and then multiply by 5, add by 2, take that absolute value, and it's going to be a positive number. Well, that makes sense that any number works because this expression says that it's greater than or equal to a negative number. So it doesn't matter what I put in there for x, it's going to come out of a positive number, and positive numbers are always greater than negative numbers. So you don't necessarily have to do the work for all of this. If we get an absolute value that is greater than or equal to a negative expression, it's going to always be all real numbers, or from negative infinity to infinity. So there's some shortcuts for 7b, where we had no solution, and 8b, where we had all solutions are negative infinity to infinity. You can definitely do the math there, though, to check and see what kind of results compare with your assumptions. So that's basically it with solving greater than or less than absolute value inequalities. The process of solving is the same, again, as solving an absolute value equation. We're solving a compound inequality. It's the setup when we get to the absolute value, how we have to remove that from these rules that we're going to have to recall. Now let's take a look at a couple word problems here. These word problems are only included in the honors notes. So my school level guys, you have completed the EI.2 notes, and we will have time to work on homework and ask questions in class. My honors guys, we're going to go ahead and complete problems 9 and 10. So problem 9 says for new cars, the number of miles per gallon a car will get is heavily dependent on whether it is used mainly for short trips and city driving or on the highway for longer trips. For a certain car, the number of miles per gallon that a driver can expect varies by no more than 6.5 miles per gallon above or below its field tested average of 28.4 miles per gallon. What range of mileage values can a driver expect for this car? So let's let M be the mile per gallon or mileage values. Let's just let M be the mileage value. If I wanted to know a range, basically what I can do to find that range is I can take any value for M, and this is something you probably did back in Algebra 1, and I can subtract the average. And that's going to give me a range. What we know is that the driver can expect this to vary by no more than 6.5 miles per gallon. So if it's going to be no more, that means this expression has to be less than or equal to 6.5 miles per gallon. Now there's one small thing that we need to put in here. This M minus 28.4 works if M is greater than 28.4. If M is less than 28.4, we need to change that equation. Or what we can do is we can create an absolute value. So why the absolute value works. If M is greater than 28.4, it gives you the difference in a positive number. If M is less than 28.4, you would get a negative number, but then the absolute value gives you a difference in the positive number. So this expression is any mileage value that is above or below 28.4, it's going to tell us the difference between that average and our value, whatever M is. And so now we can solve this problem. So this is a less than inequality. So when I want to get rid of my absolute values and I'm ready because there's nothing else included in that equation, I'm still going to have that the M minus 28.4 is less than or equal to 6.5, but now it's also going to be greater than or equal to negative 6.5. So then what we would do here is we would add 28.4 to all parts of the equation. And I'm going to go ahead and just do this on the calculator. So I'm going to add 28.4 to negative 6.5. And over here on the left, I'm going to get 21.9 is less than or equal to M, which is less than or equal to 6.5 plus 28.4, which is 34.9. So it says, what range of mileage values can a driver expect for this car? We could say that he could expect from 21.9 to 34.9 miles per gallon. Now, one real key thing here, as I put context back into this, the word from. The word from includes or implies that we are including 21.9 and 34.9. A common word that we see used when we're thinking about an interval is between. Between implies that 21.9 and 34.9 is not okay. They wouldn't be part of that range, but we can see here because of the equalities that they are part of that range. So we do need to be careful with our word choice there. You could say between and including 21.9 to 34.9 miles per gallon as well. But the word from implies that 21.9 and 34.9 are equal. Okay, so what we did here was we used an absolute value to set up an inequality that we could then solve because it was a less than inequality. If you feel confident in your ability here, go ahead and pause the video and start, or see if you can complete number 10. In number 10, it says, my stock in the Triple M Corporation fluctuated a great deal in 2009, but never by more than $3.35 from its current value. If the stock is worth $37.58 per share today, what was its range in 2009? So basically, right now it's $37.58 per share, and in 2009 they went up some and went down some, and it fluctuated back and forth. We want to figure out what the range was. So again, we don't know what the stock was worth in 2009, so let's let it S be stock. If I wanted to figure out what the difference was, I could do S minus 37.58. And what I know is that it's never more than $3.35, so it has to be less than or equal to $3.35. Now, again, this implies that S is greater than 37.1. It could have been less. So how I take care of that mathematically is I just add an absolute value. This would give us the difference regardless of whether S is more or less than $37.58. So now we can go ahead and solve. So to get rid of those absolute values, I want to create that compound inequality. This is an AND situation. It's an inclusion or an intersection. So I still have S minus 37.58 is less than or equal to 3.35, but now it's also greater than or equal to negative 3.35. Then in my calculator, I can do the work to get S by itself. So I can take 3.35 plus 37.58, which would be 34.23. And I could do 3.35 plus 37.58, which would be 40.93. So the stock value was from $34.23 to $40.93 in 2009. So we can use some inequalities here to help us write an equation. Sorry, we can use an absolute value here to help us write an equation that deals with the range. Because it is an inequality, we do need to go ahead and, once we get rid of that absolute value, we turn it into a compound inequality. So if it's less than, that's an AND or an intersection. If it's greater than, this is an or a union. And we have now finished the EI.2 notes. Thank you guys for tuning into this video. When we return to class, we will go over questions, and then you guys will have time to work on homework and preparation for our quiz. Have a great day.